G'day, Max here again, another episode in the machine shop. Well, finally I've come back to Perth full time again. I've been working away the last 5 months up in a town called Port Hedland up in the north of the state. It's basically an iron ore terminal where the iron ore from the surrounding mines gets either trucked in or sometimes it comes in on trains. There's 3 main rail networks which bring the iron ore in, and then the material just gets loaded out onto the bulk tankers, iron ore carriers, and shipped off overseas. But up there, I was involved with the project. We were building a bridge over the main Great Northern Highway. There's a major rail line that crosses the highway, so that's been alright, something different for a while, and it's also given me the funds to help move my new workshop expansion along. So, but anyway, we're back in Perth, and while I've been away, a few bits and pieces have come in that I've ordered, some tooling and that. One being this little item here, which I'll go into. This is a grinding attachment. It's basically an air spindle for jig grinding. So you can run this in your boring head on the mill. There's an air line goes in there. There's an anti-rotation arm, screws in the side, little tap hole there, and the air spindle there. So you put your grinding wheel there. Now, at the end of the day, really, it's for a milling. Well, you could use it in a lathe as well. So you mount this up, well, one way, you mount this up in your boring attachment on your mill. So you set that to roughly your diameter. The anti-rotation arm holds it still. Of course, this rotates as it's circulating. And your grinding wheel on the end grinds your hole. It's like a poor man's jig grinder. So the other item which turned up was this Federal indicator. It's an old second-hand one, but it's still fine. Why I brought this, or what really got me idea with this one, well, I've never seen one like it before, was the length. It's an 1.25 inch indicator pointer on the back of it there. So I thought that was a bit unusual. It's in half our graduations and good for getting in holes and that. So put that over there. Yeah. So the other thing on my mind was every time I come in here, I see this little thing here. Now, this was an idea I had some time ago. I started making it just out of bits of scrap I've had laying around. It's got a handle and a slide, a bit like a compound slide on a lathe. I've mounted it to the rotary table base. 4-inch rotary table base. So the idea being, I'll modify or finish machining the top of it so I can mount a tool, a lathe tool on the top. Where the drive goes in for the rotary table, I'll put an extension on the handle, and it will be a radius turning attachment for the lathe. But that's another story. That's something I do want to continue on very shortly, maybe today. I might bring you over. We'll go through that. We'll have a closer look at it. Okay, well that's brought you in a bit closer, I hope. So let's have a bit more of an explanation about this radius turning attachment. So I had this idea. Brought this little 4-inch rotary table. Get that out of the way. It's just a old cheapo one. So my first thoughts was, somehow to mount a tool on there. turn the handle, turn the tool, cut your radius. So I thought, well, we can go a bit better than that. We can machine up, because we're machinists, we can make anything. That's quite tight. There we are, there we are. It's a bit rusty. It's been sitting around for a while. So we've machined up a dovetail slide, just a piece of scrap steel. No drawings, because I've just made it as I've gone along, what was in the back of my head, and with what materials I had laying around too. So that's a 7/16 diameter square thread, and we just made up the handle. We put it in the mill, we engraved some graduations. It's a bit hard to pick. So because the thread, it's 10 threads per inch, so that gives us 100 graduations, 1/1000th of an inch apart on the dial. So in the slide, it's just a bit of 7000 series aluminium, square thread machined inside. That was a bit of an effort. I don't know if anyone's done small square threads, single point threading internally. 7/16 square thread, but we got it done. So here goes. Oh, and we've cut a slot down the side. Some grub screws go on the side just to take up any play in the slideway. He screws on. So we stole the gear, the little bronze gear, off the original rotary table that used to go onto there. So he'll go onto there. The handle, go onto there once you put the screws in. So what we'll do, set that to there. Yeah. Once we get the screws in, hold the handle, and turn this, and turn your radius. So we'll put an extension, so this handle will actually sit out a bit further, just to give you a bit better access when you're in the lathe. So we'll swing it around to the lathe, and we'll see how it mounts up. Okay, so the radius turning attachment replaces the compound slide. So we remove the compound. Out of the way. Yeah, well, that's a bit average looking in there. We must have forgotten about that in the Christmas clean-up. So the attachment picks up on the two holes for the compound mount. I still have to ease the holes out in distance to fit this rotary table. So basically at the end of the day, I've got a few 16mm shank tools which I don't use anymore. They'll be ideal for this because it puts it pretty well right on centre height. So I'll just have to make up a clamping arrangement because I want to be able to clamp these tools in any position on top of here. So whether I drill this a bit like a pallet, I'm not sure yet. I may do. Maybe a couple of T-slots or something. And then, yeah, you got your adjustments for your diameter on here. We'll put the extension, put a proper handle on it, so you can rotate it in a even fashion, and turn your radius. The only drawback in this machine, unless I might scallop a bit out of here yet, is we're stuck to about a 30mm max diameter radius. If I use this in my larger lathe, I have a 21-inch swing lathe, I'll have a lot more clearance on the top, so I'll just design a taller tool holder and it should be good. Okay, we'll come over to the little mill and we'll make a start on this. So we have to ease out these areas here just to provide a bit of clearance for the head on the cap screws. So they're a bit, they stick out. They've just got to come in a little bit, so we'll mill a bit of a relief in here. Get that going. Set the vise up, about there. T-slot bolts in, studs. Clamps. Now, just clock this in a bit, get it close. We'll just use the little stirrup, last word. Put it in the drill chuck. It'll be plenty good enough for what this has to do today. Okay, where are we? Get up there. Okay, I'm sure you guys have seen plenty of indicator shots before. That's a couple of quick taps and she's trammed 0-0. We'll set you back up over the side. Okay. Won't be needing that. We won't be needing the drill chuck, so I'll swap that out for a collet. Make sure your tapers are clean. Drawbar in. Spanner, just nip up the drawbar. So 1/2 inch end mill is the closest that I've got. These are 1/2 inch and 1/2 inch, so I've got a set of Jacobs collets, ER40. Them in. It's clean. Very close fitting thread on this one. She's not your average old cheapo collet chuck. It's actually a Mechanica brand. It's a Hungarian company and they're made in Taiwan. Okay. Yeah. We'll have to set that on a couple of parallels. See what we got. These are actually parallels I made when I was an apprentice years ago. Been a good set. Put it in that way. Take it down. Got it? Perfect. So what we'll do, we'll just line up by eye will be plenty good enough for what this is going to be doing. Lock the column off. That's it. Okay. depth. So we get real equal on the depth. Check that with a screw. It goes right in there now, that's what we want. Should be good. Do the other side. Keep the y-axis the same. Okay, lock that off. Put the table off. Down again, so we hit our 0. That's it, we're in. Good one. Just verify our centre distance. Just measuring across the outside, then we 4075, so we go deduct half an inch. And 575. Check it on our there. What I would like to do too is that'll be alright, we'll give that a try. Find my vice handle. Yeah. So we've just created a machine surface in there for the cap screw to sit on, and just a slight relief just in here, same on the other side, just so the head of the cap screw clears. Okay, well that's the base completed for the radius turning attachment. The relieved areas here for the cap screws. We'll give it a bit of a test fit. Screw in there. Perfect. That will be the dog's bollocks. So next time we will work on the tool holder design. So I'm probably going to go with a sort of a step clamp to clamp the tool down, I think, and possibly a series of holes just like a pallet. It's probably going to be the best way, because I want to use this in another application later on. I want to be able to put a miniature vise on here and hopefully use it as a grinding attachment in the tool and cutter grinder for grinding reliefs on lathe tools. That's another day, another story. So we'll leave it at that. We'll catch you later.